Hello dear students, welcome to EC Academy Benefactor. Hello dear students, in this class we will be seeing the analysis of current series feedback amplifier. The other name of current series feedback amplifier is CE amplifier with unbiased emitter resistor. In the previous class we have seen voltage series feedback amplifier analysis. So what do you mean by analysis? While understanding the circuit, we are finding out what is the gain with feedback, input resistance with feedback, and output resistance with feedback. So by looking at the circuit, how can we identify it is a current series feedback amplifier? This is a current series feedback amplifier. Other name is CE amplifier with unbiased emitter resistor RE. Why it is CE? So it's easy to understand. Whenever the output is taken at the collector point with respect to ground, it is CE configuration. And there is a unbiased resistor RE, so it is a CE circuit with bypassed resistor RE. So is an example of a current series feedback amplifier, unbypassed resistor RE in the CE configuration because the output is taken at the collector terminal with respect to ground. So there are few steps before finding the gain with feedback. RIF, input resistance with feedback, output resistance with feedback, ROF. First step is to identify the topology. So in this, identify the topology means, as you know, there are two words, current, series. The first word tells about the sampling. The second word tells about the mixing. So in a feedback amplifier, mixing is done at the input side and sampling is done at the output of the transistor or the amplifier. Sampling, mixing. So in the first step we will find what type of mixing it is. So here, how to identify the type of mixing. There are two types of mixing, series mixing and shunt mixing. So in our previous class we have already seen what are the steps to find the type of mixing. So based on that reference we can now easily understand, as the feedback resistor RE is not directly connected to the base of the transistor, it is series mixing. It is just a rough or easy way of understanding for series mixing. But technically there are few steps, written steps to be followed to know what is the type of mixing. Accordingly, when we say it is series mixing, when the feedback signal is subtracted from the externally applied signal, when the feedback signal is subtracted from the externally applied signal as voltage, then it is series mixing. This is the equation or the statement given for series mixing. Or other way of telling it is series mixing is, just by visualizing you can tell, as the feedback resistor RE is not directly connected to the base of the transistor, it is series mixing. Or other way of saying is, as a feedback signal when subtracted with externally applied input signal is voltage, it is series mixing. So the feedback signal is VF and the externally applied signal is VS. So this is a series mixing. Okay, or you can easily say this is series because it's not directly connected to the base. Now coming to why it is known as current sampling. So as you know the equation, what is VF? Feedback signal. It is observed, it is taken across resistor, feedback resistor RE. What is VF? Vf is equal to the current passing through resistor Re. So Vf will be equal to IE Re. And what is the relation between IE and IC? As we know, the emitter current is equal to sum of base current and collector current, and IB is negligible. So emitter current is approximately equal to collector current. So IE is equal to or approximately equal to IC. And what is IC equal to? The collector current flowing through this collector terminal. So it's having relation with the output current I0. So IC is flowing in this direction and I0 is in the opposite direction. So we say IE is equal to minus I0. So we get the equation Vf is equal to IE Re, which is equal to IC Re, which can also be written as minus I0 Re. So now what is the equation we are getting? Vf is equal to minus I0 times of Re, or we can say Vf is directly proportional to I0. The feedback signal is proportional to output current. Vf is the feedback voltage, I0 is the output current. As the feedback signal is directly proportional to the output current, this is a feedback signal. Signal is directly proportional to current. It means it's a current sampling. Okay. So this is one way of telling that when the feedback signal is directly proportional to output current, it is current sampling. Whereas when we are following the steps to understand why it is current sampling, we can say it in another way. By opening the output loop, that means by opening this collector point, if the feedback signal becomes 0, it is a current sampling. So by opening the collector current, what will happen? Vf will become equal to 0 because it is equal to minus I0 Re. So it's a current sampling. So this may be the more easier steps to understand, as the feedback resistor is not directly connected to the base, it is series mixing, and Vf is directly proportional to current, the feedback signal is directly proportional to current, it is current sampling. Or other ways is, when the feedback signal is subtracted from the externally applied input signal as voltage, it is series mixing. By opening the output loop, if the feedback signal becomes 0, it is current sampling. So there are two steps, either of it you can take for your convenience to understand. So finally, what did you understand? It is series mixing and current sampling. So as it is series mixing and current sampling, what is the name of the topology? Current series feedback amplifier. It is a current series feedback amplifier. Current is I0 and series means mixing. Series mixing is voltage. So what will be the gain of this feedback amplifier? Output by input. So output is what? Current I0. Input is series mixing. Series mixing means voltage Vs. So GMF. I by V is equal to GM, that is transconductance. So I0 by Vs is equal to GMF, the transconductance with feedback. So current series feedback amplifier gain is GMF, I0 by Vs. So by looking at the diagram, you can easily say it is a current series feedback amplifier. Resistor is not directly connected to the base, so it is series mixing, and by opening the output loop, the feedback signal becomes 0, or Vf is directly proportional to I0, it is current sampling. Current sampling series mixing gives current series feedback amplifier. After this first step, we need to draw the input and output circuit to do the analysis. So let us start how to draw the input circuit. To find the input circuit, so we got the name current series. we got the name current series. So for input circuit, we have to see what sampling is done at the output side. For input circuit, what type of sampling is done? Current sampling. So you have to make I0 0. For input circuit, you have to make the I0 0, current sampling. As it is current sampling, I0 is 0. So how can you make I0 0? By opening the output loop, that is open the collector point. So this is the circuit you are having. You have to open this collector point, so you are removing this point. So what we are doing now, in the second step, we are drawing input and output circuit without feedback. So first we have identified the topology name, current series feedback amplifier. In the next step, we are drawing an amplifier without feedback. This is amplifier with feedback. So in this amplifier with feedback, you are having VCC and ground. But in the second step, when we are drawing, that is amplifier without feedback, we have to remove the VCC and ground. Okay. So for input circuit, what we need to do? We have to make the samplings, currents, as it is current sampling, set I0 0. So here make the collector point open circuit and remove the ground point. So what happened? The resistor Re is connected over like this. So this is the input circuit. So what did you understand? How to draw the input circuit now? For current sampling, make I0 0, that is open the output loop. Now let us draw the output circuit. To find the output circuit, we have to find what type of mixing it is. To find the output circuit, we need to see what mixing is done at the input side. It is series mixing. So as it is series mixing, what happens? You have to make II 0. So for series mixing, make II input current 0. So for how can we make input current 0? We have to open this base point and remove the ground point and VCC also. So there is a collector resistor Re which is now connected to this common point. So we have to remove this VCC and ground. We have open circuit the base point. So this is output circuit we got. So for drawing the input circuit, we have to see what type of sampling is done. Current sampling. So make I0 0. For drawing the output circuit, we need to see what mixing is done at the input side. So as it is series mixing, you have to make II as 0 by open loop the input circuit. So now we got input circuit and output circuit. So now we need to club these two. So the third step is to draw the amplifier circuit without feedback with approximate model. So we have clubbed these two diagrams. This is input circuit. So it is drawn here. And this one is the output circuit. So these two diagrams are clubbed here, input circuit and output circuit. Okay, so now what you have to do, you have to replace this transistor with the approximate H model of, so this is the approximate H model of the transistor. How to draw the approximate H model? What is the name of the configuration here? It is CE amplifier. So emitter point is common to input side and output side. So we have taken the three terminals, base, emitter and collector. As it is approximate model, we are using only two H parameters, HIE at the input side, HFEIB, that is a base current, HFEIB output current at the output side. This is known as approximate H model of the transistor. So in this circuit, what is the name of this circuit? This is amplifier circuit without feedback. So now input side is same. Vs, Rs and Re. So these three are there already. We have replaced this transistor by the H model, HIE, HFE, IB, and these two resistors are already there, Re, Rc. Okay, so what is the name of this diagram now? This is an amplifier circuit without feedback with approximate H model. So Vs plus minus Rs, HIE, IB current, Re. This is a base point, emitter point, collector point. HFE, IB. This is Re across which you are observing. So here we won't talk about VF because this is the amplifier without feedback. Just I have written it here once for next analysis when it comes. So this is not required here. Okay. RC is the output. Here we observe the output voltage through which the output current I0 is flowing. So till now what we have done? So first we have drawn a circuit. What is the name of this circuit? This is a current series feedback amplifier. The other name of this amplifier is CE amplifier circuit with unbypassed resistor Res. Why it is a CE amplifier? Because the output is taken at the collector. So we got a current series feedback amplifier and we are doing its analysis. So first step is to find its topology, which we have identified the topology as current series feedback amplifier, and in the next step we have obtained the input circuit without feedback, output circuit without feedback, and clubbed the both input and output circuit and replaced the transistor by its approximate H model here. So based on this diagram now we'll be doing the analysis. So what parameters we need to do derive while analysis? We need to find what is the gain with feedback, what is the input resistance with feedback, what is the output resistance with feedback. So these are the three parameters we need to find. So before finding all these, this is the transconductance gain with feedback, input resistance with feedback, output resistance with feedback. Before finding all this, we need to find without feedback, that is GM. We need to find first GM, Ri and R0. So based on this you will get all this. This is with feedback, this is transconductance without feedback, input resistance without feedback, output resistance without feedback. So first we need to find GM, Ri, R0 based on this diagram. So let us start with GM. What is GM? It is a transfer gain of open loop circuit, or other name of this is transconductance open loop gain. So what is GM here? Gain is what? Gain is what? Output by input. Output by input. What is the output here? It is a current series. Current means output per term is I0. Series mixing means voltage. I0 by Vi. So what is I0 here? If you observe, if I0 by Vi. I0, if you see this circuit and apply KCL, I0 is going in this direction and HFE IB is going in this direction. Both are moving in the opposite direction. So it will be I0 is equal to minus HFE IB by Vi. And what is the input signal Vi without feedback? That is Vs. So we have written minus HFE IB by Vs. And what is Vs equal to? If you refer this diagram, what is Vs is equal to? Vs is equal to IB times of Rs plus IB times of HIE plus IB times of Re. There are three resistors. The current flowing through these three resistors is IB. So it is written as Vs is equal to IB times IB taken common Rs plus HIE plus Re. So IB get cancelled and you are left with minus HFE by RS plus HIE plus RE. So in this way we obtain GM. So GM is coming to be as minus HFE by RS plus HIE plus RE. Now this is the sixth step to find beta. Indicate I0 and VF and calculate beta. So what is beta? It is a feedback ratio. What is feedback ratio? Feedback signal by output current. The feedback signal is VF because it is current series. It is current series. Current series means this is input. Input is series. So what will be the input? Voltage. So definitely the feedback signal here is VF. So here beta is equal to feedback signal by output current. So current is output sampling, VF by I0. And what is VF equal to? If you see here, what is VF equal to? VF is a voltage taken across RE. So it will be how much? IE times of RE. VF is equal to IE RE. And what it is equal in terms of I0? If you see this IE and I0, both are in. If you apply the KCL here, what will happen? IE plus I0 is equal to 0. So IE will be equal to minus I0. So we have written IE is equal to minus I0 times of RE. So I0 get cancelled. So beta is equal to minus RE. And we got the equation of GM. GM is equal to minus HFE by RS plus HIE plus RE. And beta is coming as minus RE. Now we need to calculate in the second step what is D sensitivity. D is equal to 1 plus beta GM. Beta is equal to minus RE and GM is equal to minus HFE by RS plus HIE plus RE. So what will happen? This minus become plus. So 1 plus RE HFE by RS plus HIE plus RE. We got D sensitivity D. Now it's easy now. Once we find GM and beta, we can find GMF. What is GMF? Transconductance with feedback. So what is GMF? GM by D. GM is what? Minus HFE by RS plus HIE plus RE. And D is equal to this one. We have simplified it. This D equation. RS we have taken it over here. And on simplifying we got the D equation as RS plus HIE plus RE times of 1 plus HFE by RS plus HIE plus RE. This is the D equation. We are substituting here. So GM is minus HFE by RS plus HIE plus RE by D. So this denominator came up, RS plus HIE plus RE, and the numerator is here, that is RS plus HIE plus RE 1 plus HFE. So these two get cancelled and it is coming to be as GMF is transconductance with feedback is coming to be as minus HFE by RS plus HIE plus RE times of 1 plus HFE. So we could first get the first equation GMF. So the equations quickly we can see. GM is open loop gain, GMF is closed loop gain, that is without feedback, and this is with feedback. GM is output by input, output I0 by VI, this is I0 by Vs. Now we can find voltage gain also in this. Voltage gain AVF is equal to V0 by Vs. And what is V0? V0 is equal to I0 times of RL. In this, if you see, here we written as RC. Okay. So what is V0 here coming to be as I naught times of RC. Okay, so it is written as AVF is equal to V naught by Vs, and which is equal to I naught times of RC by Vs. So it will come as I naught by Vs. What is I naught by Vs? It is equal to GMF. So what is the voltage gain with feedback? AVF is coming to as GMF times of RL. Now next parameter to be obtained is input resistance, RI. RI is equal to total resistance present at the input side. What is the total resistance present? RS plus HI plus RE. That is the RI. That is written here. RI is equal to RS plus HI plus RE. Next we have to find input resistance with feedback. RIF is equal to RI times of D. What is the name of the feedback amplifier? It is current series. Current series means mixing. Mixing is done at the input side. So what type of mixing it is? Series. Series means the resistance increases. Resistance increases means we need to multiply Ri times of D. Ri we have already obtained, that is Rs plus Hi plus Re into D, and D we have already done it here, this equation. So Ri is the total resistance present at the input side. As it is series mixing, the resistance will increase. So we are multiplying RIF is equal to Ri times of D. Now output resistance. Output resistance R0 is equal to infinity. ROF is equal to R0 times of D, which is equal to infinity. Now we can find ROF dash, which is equal to R0 dash dot 1 plus beta GM by 1 plus beta GM. So ROF is coming to be, ROF dash is coming to be as R0 dash, which is equal to R0 parallel to RL, which is equal to infinity parallel to RL is coming to be as RL. Okay, so in this way we can easily do the analysis of current series feedback amplifier. The main equations which you obtained are GMF here. GMF is coming to be as minus HFE by RS plus HIE plus RE times of 1 plus HFE, and RIF is coming to be as RS plus HIE plus RE times of D, and ROF is infinity, and ROF dash is coming to be as RL. I hope you have understood the derivation of current series feedback amplifier. If you have any doubts, you can post in the comment section. Thank you. Good luck, students.